All right, so the first little item of business is to think about the domain and range of sine and cosine. So if sine is the y value of the place that the terminal side of our angle is going to intersect the unit circle, it's going to start, the y value starts at 0, and it goes up to, what's the biggest that the y value can get? 1, right? And then it's going to get smaller and smaller. We're thinking about the y value of the point on this circle. Now it's going to be negative and go all the way down to -1 and then back to 0, right? So our domain of, the range of the possible y values for sine as you go around here is -1 to 1, right? How about our domain? What values make sense as inputs for sine? Really anything, right? Because we can go in the negative. So that would be what angle measurements we can use. We can go in the negative direction. We can go in the positive direction. We could go as many times around as we want, right? T could get as big as we want or as negative as we want. So our domain is all real numbers. Range for sine goes from -1 to 1. Cosine is going to be very similar, right? The inputs are going to be all real numbers, and the range, the output values, the x values for cosine are going to go from 1 to -1 and then be stuck in between those two values, right? So for both sine and cosine, the domain is all real numbers, and the range is -1 to 1 because we're stuck here on this unit circle, okay? All right, so let's go back and talk about something we talked about a little bit before, which is reference angles. So remember, here in quadrant 1, the reference angle is just the angle itself, okay? In quadrant 2, remember the reference angle is the smallest acute angle that goes between our terminal side and the x-axis, so t prime. How about in quadrant 3, it's going to be this value here, right? So here's our t, and this is our reference angle. It's the smallest angle between that terminal side and our x-axis. And same thing here. Here is our reference angle, okay, in quadrant 4. There are these equations that you can look at. I find the equations really complicated and hard to think about. It's much easier for me just in the problem to ask, okay, how could I figure this out? So for example, here's an angle that's 225, and they ask, what is the reference angle? Okay. Well, the reference angle is going to be this angle here between this terminal side and the x-axis. So it's going to be this angle, 225 minus what? 180. So 225 minus 180. So you have this complicated absolute values and stuff. It's going to be 45 degrees. Okay. And remember, our reference angles are always positive, and they are always acute. They're always between 0 and 90 degrees. All right, so it's going to be 45 degrees. It would be 225 minus 180. All right, let me move my little video. All right, so using reference angles to evaluate trig functions. Here is an important idea. Angles have cosines and sines with the same absolute value as the cosines and sines of their reference angles. Okay. So an angle has the same cosine or sine value as its reference angle, except for the sine, perhaps. Okay, the sine might be different. So it could be positive or negative. But the value of the absolute value of a sine or cosine of an angle is the same as its reference angle. All right, so let's go back. We were talking about this before. These are our special angles that we need to remember these values, okay? These are the things we're going to use as we are determining sines and cosines of other angles. They're all going to come back to these special angles that we talked about before. Okay, so we'll refer back to this. So let's think about this. On the unit circle, here's our special angles. We've talked about just quadrant 1, 30 degrees, 45, 60. Right, those are our special angles. Here's our sine and cosine, sine and cosine, sine and cosine. Or I guess cosine and sine, right? We talked a little bit about the quadrantal angle, right? 0, 1. All right, so how could we figure these out, for example? Let's look at this one right here, 150 degrees, okay? What's the reference angle for 150 degrees? Well, it's going to be 30, right? because there's 30 degrees between that and the x-axis. So the reference angle for this is 30 degrees. Here's 30 degrees. So the values for cosine and sine are the same. And now we use the quadrant that it's in to figure out if they're positive or negative. So tell me, in quadrant, is the x value, the cosine, is this positive or negative in quadrant 2? It's negative. Look, all of the x values, all of the cosines are negative, right? We're going along the negative x-axis here. And all of the y values, all of the sines are positive because we're in the positive y direction, right? So this corresponds to this corresponds to that, this corresponds to that, except for some pluses and minuses. How about this? What's the reference angle for 210? That's also 30 degrees. So this corresponds to this, this to this, this to this, right? The reference angle for 240 is 60 degrees. And in this quadrant, the x value is negative and the y value is negative. So all the x and y's, all the sines and cosines are negative. You can think about the same thing here, except the x value, the cosines are positive, and the sines, the y values, are negative. Okay, so this looks super complicated. There's like numbers and radians and degrees all over the place. But take a minute and look at this. Again, it's all coming back to these same three angles, and these three angles only have a few values. Before long, you're going to be able to fill this whole thing out, and it won't even seem hard. Okay? This is the first time you're seeing it, so don't worry if it's not easy now. It shouldn't be. Okay? But I'm telling you, you're going to get the hang of this. All right, so let's use this. So here's some steps. If you want to read through them, you could pause and read. Using reference angles to find sine and cosine. Let's do these two examples, and let's go over to the video. All right, so let's do it. Using reference angles, find the exact value. So exact value means we want it in terms of like square roots and things like that. We don't want a decimal approximation, because otherwise you could just put this in your calculator, right? Not what you're asking you to do. Don't ask you to just put it in your calculator. I'm asking you to actually find the values. So cosine of 150 degrees and sine of 150 degrees. So let's just think about this. 150 degrees. Okay, so here's 90, here's 180. It's going to be somewhere like that, right? This is 150. The reference angle here is 30 degrees. Okay. All right, do we know what sine and cosine of 30 degrees are? Maybe not yet. You will soon. Let's just look. 30 degrees. Cosine is square root of 3 over 2. Sine is 1/2. So we can say cosine of 150 degrees equals square root of 3 over 2. And sine of 150 degrees equals 1/2, right, from our little table. Now, are they going to be plus or minus? Let's think. Here we are. The x-axis, we're on the negative x-axis, positive y. So this is going to be plus, and this is going to be negative. Okay. What about this next one? 5 pi fourths. Let's think about this. 5 pi fourths. Well, that's more than pi. So it's going to be past here and 1/4 more. So I think it's going to be here, 5 pi fourths. So what's the reference angle? Well, let's see. In this, I'm going to subtract, this is in radians, right? So I'm going to subtract pi. So 5 pi fourths minus pi is pi fourths. Cool. That's my reference angle. So let's go back here if we don't remember. Maybe you're starting to remember already. That'd be awesome. For pi fourths, cosine and sine, remember this is a 45-degree triangle with its right isosceles. So the same, they're both square root of 2 over 2. So sine of 5 pi fourths equals square root of 2 over 2. Cosine of 5 pi fourths equals square root of 2 over 2. And are they positive or negative? Let's see. In this quadrant, the x value is negative and the y value is negative. So they're both negative. So they're both negative there. What if the question asked, let's see, I'll pull this down. Find the coordinates of the point on the unit circle at an angle of 7 pi sixths. So what's this asking? Here's our unit circle, 7 pi 6, this is 6 pi 6, so it's a little bit past it, 7 pi 6. So this is 7 pi 6. So what's the reference angle is going to be pi 6 here. Right? So it's asking the coordinates of this point, which is really just the cosine and sine. Right? All right, well, pi 6, that's one of our angles we need to know. Pi 6, cosine is square root of 3 over 2, sine is 1/2. So cosine of pi 6, or 7 pi 6, equals square root of 3 over 2, and sine of 7 pi 6 equals 1/2. And are they positive or negative? Well, in this quadrant, they're both negative, right? X is negative, Y is negative. So negative, negative. And we could say the actual coordinates of that point are negative square root of 3 over 2, negative 1/2. And that would be our answer. Okay? So that's how you use reference angles to find exact values of sine and cosine, different sine and cosine angles. All right, using reference angles.